Hello and welcome to today's webinar entitled How to Use Electric Radiant Heating as a Primary Heat Source. I'm Scott from WarmlyYours, and
I'm Anatoly.
And we are the Merlot twins today. As you can tell, we got the memo this morning to make sure we were the right stuff. So let's go ahead and get started. I got to press the right button. I apologize. So if you have any questions during the presentation, feel free to ask them here. Just click on the Ask a Question section there at the bottom of the screen, and we will be glad to answer any questions that come along. Also, we'll be having a question and answer thing at the end. So if you'd like to get your thoughts together and just give them to us at the end, you're more than welcome to do that too. So let's take a look at what we're going to be talking about today. We're going to be talking about radiant heating. Obviously, that's why we're all here. We're going to be talking about the heat loss calculator and products and controls that are used that we're speaking about. So what exactly is radiant heating?
Great question. So radiant heating is, first of all, just one of the main three ways of transferring the heat. For example, the human body produces heat and then it's lost into, surrounding cooler atmosphere environment. Successful heating system will want to minimize that loss to make you feel comfortable. Typical kind of convection heating will focus on the warming the air, while the radiant heating specifically warms the surfaces of objects through those infrared waves. That's why it's so great.
Yeah, I've walked into many people's homes who have just put radiant heating in their bathroom, and they're used to their house being heated with hot air. So what they expect is when they walk into this room, they expect to, it's like opening an oven. They expect to open the oven door and be hit by a blast of hot air. Well, that's not what radiant heating feels like. So a lot of people who have had forced air heating for a long time, and now they put it in their bathroom or something like that, they don't realize that you're not going to walk into an oven feeling thing with hot air blowing on you. After you're standing in there a couple minutes, though, you can really tell. When we're in testing a floor, making sure it's okay, a lot of times by 3 or 4 minutes in, you're going like this. The air is not really that warm in there, but it's warming you. And we're going to be talking about that here in a little bit. So the way we actually heat things with the radiant floor heating and also with radiant panels are both the same idea. And I just got this question yesterday. What type of wavelength is it and what does it mean to me?
Yeah, so radiant heat falls into that far infrared wavelength. Of course, we don't see that wavelength. We don't hear that. It's not a radio wave or anything. It's just the same feel, the same type of heat as you feel coming from a fireplace, coming from the sun on that, even a cold day outside. But if you're staring right at the sun or just feeling that heat, it's really going to be very, very similar. You're just feeling, you're absorbing that heat.
Yeah, the special trick here to understand radiant heat. In the summertime, to get away from the radiant heat, you go under a tree because the far infrared rays are actually hitting the tree between you and the sun. And also, it's that time of the year. We had 2 days of fall this year. So if you were happy on one of those 2 days of fall, then you might have had a campfire one of those 2 days. And what I always like to do, an example, is if you're sitting in front of a campfire, you're sitting there, it's nice and warm until somebody comes up and starts talking to you. And they stand between you and the fire. Sure. Now, all of a sudden, their back is really warm and you're freezing because all the far infrared waves are actually hitting the person talking to you in the back instead of getting to you. So that's how the far infrared does. It's line of sight, especially if you're putting in like radiant panels in your room. If you put up a radiant panel on the wall and then you put a scrim in front of it, it's just going to warm the scrim. It's not going to get to you. So it's kind of like line of sight. So what we're talking about here, the spectrum of heating, is really for radiant panels and for floor heats. It's the same spectrum. So let's talk more about these types of heating.
Yeah, so like I mentioned previously, there's of course those three main ways of transferring the heat. Convection, that's when you're transferring the heat through like a medium of fluids, so gases or liquids. So on that picture, we can kind of see, convection is eventually that sort of hot steam or hot liquid just in the cup. Conduction is the transferring of heat by a direct contact. So that's eventually when you grab that hot cup of coffee, it's going going to be hot. The surface is going to be hot because that liquid just conducted the heat directly to the surface. And in the very end is the radiation. That's what we were just saying. We feeling. If you put your
Hands around it.
kind of hold your hand right next to the cup, you're going to start to feel that warmth coming.
So let's take a look at electric radiant floor heating. I like this drawing, but I would love it if it was actually in a basement. For the people in Texas and the people out west that don't have basements, you don't really understand what we're up against here in the Midwest and other parts of the East and that sort of thing. People with basements, is forced air, usually in a basement, actually comes from above. And a lot of those vents are blowing hot air down. Well, we know hot air likes to go up.
Doesn't like to stay down, for sure.
It doesn't like to stay down. So the hot air goes up. But we're not really always talking about hot air. We're talking about warmth from far infrared waves. So those far infrared waves are kind of going to wherever it can reach. So if we take a look at the radiant heat shot on the left, you can see that the warmth is coming from the floor. If you take a look at the room on the right, you'll kind of see where the hot air goes straight up to the ceiling. And then as it cools, it comes back to the floor. Well, you're not sitting in the ceiling. You're actually sitting on the couch with your feet on the floor. So all you're going to feel is that cold air coming down across your toes and going into the cold air return. And then all of a sudden you're sitting there and you're cold and the air above you is nice and warm.
And the right shoulder, you have like 110-degree air blowing into it. So yeah.
Okay. It sounds like we might have some trouble with hearing. We have no audio. Is that true? Can anybody hear us?
Scott said yes.
Scott, yes, you can hear us or you cannot hear us.
Oh, great.
I can hear.
Like
okay,
we
good.
Definitely have people.
All right. Well, thanks. It's a roll call. Thank you all for joining in. We know you're alive. So for you folks that are not able to hear us, you might just want to maybe reload the page. Load and loud and clear. Okay. Our unpictured assistant over here, she's kind of working the magic keyboard, so she'll be taking care of you there. So that's kind of like the idea here of what is so good about using this type of heat as a sole source of heat. It's actually heating objects in the room. It's heating you. And as those objects and you become warm, you start giving off warmth into the air. Right? Did I get that right?
Yeah. I mean, the biggest, there's of course obvious information on that image, like, hey, you have, with a forced air, you have hot air in one side and just cold on the other. And like Scott mentioned, it's really not going to be that comfortable for some of the cases. The part I like about the radiant heat, the picture on the left, or, the room on the left, is that you really have nice and average temperature throughout the whole room. First of all, your floor is nice and warm because that's what's the source of heat is. And the temperature is distributed evenly throughout the whole room, and more towards the ceiling, it's really not that hot. And because you don't really need to be the temperature that hot there.
Yeah, the room on the right is very, very similar to a room here. We sometimes in the Midwest it's called a bonus room, which is usually over an unheated garage, or they sometimes put bedrooms over unheated garages. Those types of rooms are perfect because you can actually heat the floor, and that then makes the rest of the room, because these bonus rooms and these bedrooms above are literally, if you're sleeping in this bed, all the hot air goes to the ceiling. Then it comes down and gets you cold on the way down, and it just makes this never-ending circle of hot air turning to cold air. So that's one thing that these are really good for the basements, like we talked about, getting the heat in the floor, and also these bonus rooms or bedrooms over an unheated garage. So let's talk about the health benefits of floor heating. Well, the main thing with floor heating is you don't have a lot of hot air, right?
Yeah, that's number one thing.
And that hot air is not blowing around dust, allergens, that sort of thing. It's not making hairballs in the corner from the cat or whatever. The problem with this is what about the floors? Because it seems to me like the floors that are easiest to heat sometimes are the coldest, right?
Yeah, I mean, typically those floors, just like Scott said, the easiest to clean would be cold. Yeah, because we mostly talking about, let's say, tiles or any surfaces like that, right? They typically going to be cold because they absorb the heat and the cold real quick. So that's what, without a floor heat, of course, it's going to be pretty chill, pretty cold, but adding the floor heat to it really gives you that fast heating times, because those materials are typically faster to heat up, faster to transfer the heat. So they really pair up really nicely with the floor heat. You can achieve kind of quick heating, run it on demand any way you want.
Yeah. So the good thing is, even though these particular types of floors are easy to clean, they can feel chilly, but these are the easiest ones to heat also, because they transfer the most heat. So that's what's so good about floor heating under these types of floors. So we get this question all the time. My room is 10 by 10. It's got an 8-foot ceiling. Can I use this as primary heat? We really don't have an answer for that, do we?
Yeah, we trying to be realistic, and we don't want to give a straight yes or no answer, because there is just way too many variables to properly answer that question. And that's where we're leading to with, primary source of heat versus comfort source of heat. To properly understand if any source of heat can be a primary source, you really need to do a heat loss calculations, find out how much heat that particular room is losing. And it's not only square footage and the ceiling, it's your zip code, it's your climate kind of temperature information, all the R values, number, sizes of windows. There's a good list of items that we're going to be covering today. So that's doing the heat loss is what gives you a proper answer to that question.
Right. You're going to be supplying the information to this particular program, and you're going to be telling, after you're all done, telling it what types of walls you have, what types of ceilings, what's under your floor, what's above your ceiling, how many windows do you have that lose heat, how many fireplaces do you have that lose heat, how many 11-foot, 12-foot, 15-foot ceilings that lose heat. You put all that information in, and this program will actually tell you, okay, this is the number of BTUs you need. Then what we do is we say, okay, then all the floor heating in here, if you heat this particular part, will tell you how many BTUs are able to be made. So what you do then is you just compare what BTUs are needed in this room compared to what BTUs are available to heat it. And it's either yes or no.
Yeah, pretty simple decision at the very end.
Right. But there's so many different possibilities of insulation, ceiling height, how many exterior walls. There's so many different combinations. We can't just give you an answer, yes, oh yeah, that'll work. We don't do that. That's where this program comes in. So we had one question, and it was about BTUs. Normally you can take the number of watts that the product, like say a roll of heater, and you take the number of watts and you multiply that by 3.41, and that'll give you the BTUs. So 1 watt equals 3.41 BTUs when it comes to this calculation. So that is kind of where it all starts from. You tell us about the room, the program tells us how many BTUs it needs, and then it plugs in what size of the heater it is. It's 3.41 BTUs per watt. So, yes, I just answered that question, but thank you. Oh, there's more questions?
Yeah, it looks like Scott is asking about providing pros and cons for the different floor types, like tile, vinyl, wood, laminate, carpet.
Mm-hmm.
And to answer your question, Scott, in terms of a heat transfer, I think you're asking about from kind of heating perspective, the pros and cons.
Part
the
of it.
Pros would be that materials like tiles, I mean, ceramic tiles, the materials with a good heat transfer ratio is something that you most of the time would want to consider, because that type of flooring will heat up faster.
Mm-hmm.
As soon as you turn on the system, it absorbs that heat faster comparing to something like wood or carpet, right, Scott?
Well, the thing is let me put this in NASCAR terms. If anybody out there is NASCAR, you take two identical race cars, right? You take one that has a restrictor plate on it that only allows so much gas to go into the carburetor, and you race that against one that doesn't have a restrictor plate that can go as fast as you want it to.
I see where you're going.
The tile has no restrictor plate because you can get it 99, 100, 104 degrees, whatever you want it to do. But if you have carpet or if you have laminate or engineered wood or something like that, those manufacturers usually say you can only heat this up to 85 degrees. there's your restrictor plate. Anything that has a restrictor plate, like, or maximum temperature, like carpet, like laminate, like engineered wood, vinyl.
Yeah.
Vinyl is very, very susceptible to heat, or can be affected by heat. So the manufacturer will always say, you can heat this as long as it doesn't go over 85. So now, if you had the choice, you can now put this flooring in that can only get to 85 degrees, or you can choose this flooring that can get up over 100. Which one would you say is the better choice to act as primary heat?
I like that fast NASCAR.
Yes, because you're not restricting it. So consider that if the product you're buying has a temperature restriction, that's a restrictor plate. It's limiting what you can actually fill the room with, because you can only get the particular floor to a certain temperature. So 100 degrees can be for an extended period of time. Yes, Tracy, but it can also, it's not going to burn you at all either. For extended periods of bare feet on floor, think about how long you do that your feet are actually in contact with the floor for long periods of time. It really isn't that often, unless you're cooking or whatever. That's 84 or 85 degrees. But if no one's in there and you want to get that room warmed up, 100 degrees doesn't hurt anybody or anything. So that's why we're talking about when you get in there, you get the room up to 100 degrees, possibly not the room, but the floor. But once again, that floor is not going to feel 100 degrees. It's only going to be, that's the maximum that you can program the thermostat up to. What we're trying to get at is no restriction on the tile there is on other flooring. So,
and just to probably share more information with Tracy, all of our thermostat has a floor temperature limit setting that, for example, you want to heat that room to a particular temperature, but you just don't want to stand on that floor at 100 degrees. You can always limit it at 90, limit at 85, kind of put your own restrictor plate there, just because you don't want that floor to be running too hot.
Right.
So it's always possible. You don't need to stand on a 100-degree floor to make your room warm.
What we're trying to get across is a room that has a tile floor, it may make the room nice and warm. A room, that exact same room with the restricted temperature flooring type may not get to the comfort level you want.
Yeah.
That's what you're up against. So as long as we're all straight on that. I like to call these things heat loss monsters because you can just picture them as opening their mouth and grabbing the available heat and sticking it in their mouth and getting rid of it.
That's perfect light for Halloween.
Yes. Yeah. So too bad we just missed that. But sources of heat loss, people never really think about this. What are some of the things we call heat loss monsters? Some of them you can see in this room, and what are some other ones that you can't see in this room?
Yeah, so you can easily spot the things like, huge windows all around that room. We cannot see a fireplace or skylights, but once again, if there would be a fireplace and skylights, these are huge monsters too. In this particular sunroom or, 3-season room or so, you have at least 3 exterior walls, looks like. So that's, again, going to contribute to the heat loss because you're losing heat through the walls.
Mm-hmm.
That's as simple as that. Space under a room, if it would be like unheated crawl space or so, that's where you're going to lose even more heat. So that picture here is really kind of having few of these monsters.
Mm-hmm. So let me ask you a question. Let's take a look at those windows on that picture. Would this room be warmer if there were no windows there, or if it were the windows shown with the same number of BTUs available?
If we have less windows or no windows, and it would be just a wall with a good insulation, then the particular room should be warmer because you're going to lose less heat.
Okay, let's take a look at this picture and look at this vaulted ceiling. You have this vaulted ceiling, or you have a ceiling that's 8 feet high. Which room is going to feel warmer with the same number of BTUs?
Definitely without a vaulted ceiling.
Right. Okay. Let's say that you have in this room, let's say that there's a kitchen down below this floor. Okay. Or that there is an unheated crawl space under this floor. Which room would feel warmer with the same number of BTUs?
Heated kitchen would be definitely better.
Okay. One last example. A person with a room like this probably has at least 3 exterior walls, right? We just don't see the other 2.
Yeah.
Let's say that we move this to a bathroom on the 2nd floor. This bathroom has 0 exterior walls. Would that room be warmer than a bathroom situated like this that has a bunch of windows, that has 3 exterior walls?
Yeah, you take those 3 exterior walls out, you killing those 3 monsters right there.
Right. So when someone calls us and goes, I have a 12 by 12 bathroom, will this act as sole source of heat? You can see now why that we don't know the answer to that, because just like we went through, you choose different kinds of walls, you get different results. More windows, more heat loss. More skylights, more heat loss. More fireplaces, more heat loss. All of these things are letting heat out of the room. So the power you're generating, the heat you're generating has all of these ways to escape. What would be perfect is a room with no exterior walls, a 4-foot high ceiling. You couldn't fit in there, but you can kind of get the idea. You change the constraints of where those BTUs are placed.
Yeah.
And now all of a sudden those BTUs in a small room feel really hot. In a big room with really high ceilings, with lots of windows, it feels cool. So let's take a look at this magical thing we call the heat loss calculator. This is the first step to finding out whether your room can act as or your heat in this room can act as a sole source of heat. So explain to me what's going on here.
So first of all, you can always find that page. That's our floor heating heat loss calculator. It's available online on WarmlyYours.com. So any moment you have time today, tomorrow, or next week after the webinar, feel free to stop by. You always have access to that, but that's where it all starts. You go there, you click your heat loss calculator button.
Right. Now, Scott had a question. If new construction, what is the best value for subflooring? Concrete slab with insulation on top? I don't go out and buy subfloor materials all the time. We can tell you what it costs for the heating materials, but I don't know what concrete sells for in your neighborhood. But the idea here is you want some sort of subfloor where it is not going to steal the heat.
Yeah.
And if you are going to use a concrete slab, the insulation needs to be on top of the slab between the wire and the slab, because you want the heat to go up, not into the slab.
And also a good edge insulation kind of throughout the house, depending on the whole construction factors and stuff.
Right. If this were a second floor bathroom above a kitchen, we don't really care. We have enough watts in that floor with it, because we're going to start with that floor is automatically going to be like 70 degrees anyway. It doesn't take a lot of BTUs to get that floor really warm. However, on a concrete slab in a three season room, we don't want that temperature to get sucked downward. So if concrete slab works for you, as long as you put a layer of Cerasorb over the top of it, which is an insulating board, and then put the heat on top of that, then you should get better results, much better results than if you just put it right on the concrete slab, which we don't ever want you to do. Can we move on to the next one?
Yeah, sure.
All right. So here's where we talk about the room basics. So go ahead and run through this with us, Anatoly.
Yeah, so that's pretty much a step-by-step, we're going to try to cover all of the steps that would include here in the heat loss calculation process. Typically, if it's a new project that you're trying to set up or just a new calculation that you're trying to do, the system will guide you to create a room. You're just going to give it a name, add your zip code, put the room type, room name, just some general information so we can get the basics started. Mm-hmm. So just follow the prompts. There's usually just drop-down menus where you set all the information in and just go to the next step.
So when we're picking those, our particular program that we use for this presentation doesn't show drop-downs. If we go back to the page before, you can see each one of these has a drop-down. These drop-downs are not visible in the program, so that's why we're showing you this on the next page. So what it's doing here is, what are these things? What are we choosing here?
Yeah, so the first kind of image of the drop-down on the top, eventually the whole list of main flooring types that really should cover all possible flooring types that we usually heat. So just pick the correct flooring type with the correct installation method. So, if it's an engineered wood, make sure to specify is it floating, glued, or nailed down, because later in stages, it will help us and help our design team to properly pick the right heating product and the right installation method. So it sounds like it might be not a big, game changer here, but it's still going to be important, because a different type of heating product will dictate how much BTUs we can actually provide. So yeah, it's very, very important.
Yeah, if you take a look at this last bullet point, choose subfloor type. That gets to the question that Scott had about the subfloor. An existing concrete slab as opposed to wood. If you have wood, you don't need to worry about insulating the wire from the wood, because there's not a whole bunch of heat loss there like there is with an existing concrete slab. So moving on to the next part.
Yeah, pretty much after creating the room, it's really that first step is more of a creating just a project information. Then the system just going to guide you what actually you want to do with that. Because as you can see here in the image, you have quite a few different options. You can just go to online design tool and start designing your room and kind of get us the floor plan that way. You can upload the floor plan. You can just save it for later. But what in our particular case, if we're trying to get the heat loss, we just choosing the heat loss calculator, and that will get us into the actual tool.
I think we've already done an online design tool webinar or one of our presentations about that. So if you want to learn about that, that's in another one. Just go into our video section and that will be there. So now we move on to the next thing. And here's where we start adding heat loss information. Here's where these drop downs are going to really affect what BTUs are needed in that room, right?
Yeah, that's pretty much a step one, the very first step of the actual heat loss input information. So yeah, that's where almost every single field on the form here has a direct impact on your final results. So, zip code, somebody would ask like, what's about the zip code? But we pull the data from, just kind of general ASHRAE data that helps us to understand what are those outdoor temperatures and factors to properly understand what's the heat loss would be. So yeah, put the right zip code. Total surface area would typically already be duplicated from that previous step, but that's of course your biggest number that tells us how big the room is. Then desired ambient temperature. That's the thing where you also want to be realistic, because the higher the temperature you set here, the calculation is going to be done differently, assuming that room is nice and warm, and of course it's going to lose more heat. But if you set it maybe like the example here, average 68, then that heat loss level going to be lower, because you're not losing that much heat if you have more normal temperatures inside.
Mm-hmm.
And of course, things like sealant factor, that's just gives us a starting point, kind of ballpark of what are we talking about. Are we talking about a brand new construction with like no cracks, nice, perfectly sealed doors, windows, all that? Or are we talking about, kind of average options where it's older homes with, some gaps, some cracks that start to lose more and more heat?
Mm-hmm. My father grew up in a farmhouse, and it was born in the same farmhouse, and they didn't have an indoor bathroom. So I would use an example as a bathroom for him, but they didn't have a bathroom where he grew up. They had to go outside. So let's pick a 10 by 10 living room in that house that he was born in, he grew up in. Farmhouses either had newspaper stuffed in the gaps between the wall and the outside wall, or they didn't have any insulation at all. So that would be, which one of these would that fall under?
That would be very close to worse, if not the level down.
Yeah. So that would be visible gaps around the doors and windows. Sometimes you could actually see from the inside to the outside. He also just built a new house about 5 or 6 years ago. Which one would that probably fall under?
That should definitely fall between best and good.
Yeah. So you can see a 10-foot by 10-foot room here, the BTUs may not be enough to heat, but a 10 by 10 room here probably are enough to heat. So there's a lot of this is based on common sense, and what Anatoly is trying to give you, or is giving you like the nuts and bolts here. What's really important, I'm trying to give the overview as to what you're going to run into. You're going to run into, if you're a pro, you're going to run into really old homes, and you're going to be building brand new homes. You have to understand what's built into those also. There's caveats with older than there are with newer. So thank you. And let's talk about under the floor.
Yeah. So step 2, as soon as you got all the information put in step 1, go to the step 2. And something that I want to add right away here is, like, if you don't have some piece of information, or like in this particular example, maybe you don't have the insulation type R value, try to pick at least some realistic or maybe even worst case scenario number, because that way the system gonna generate a heat loss based on that maybe worst case scenario for the underfloor insulation type. Mm-hmm. But you don't want to just like skip or
don't always put best if it's not
or
best.
Don't put the best, because then you suddenly, like, the system gonna think, oh, okay, there's just 10 BTU heat loss on this particular wall, while in reality, it's a huge monster there.
Right.
So yeah, step 2 is pretty much all the underfloor information. So again, we're duplicating floor area. It's 100 square feet. We're selecting what's under the floor. That's the part we were already talking a little bit. So, is it unheated basement, open crawl space, or it's just a heated room? And anytime you're selecting something like an open crawl space or something that would have an insulation, the system then will prompt you to pick what R value that is. And the good part about almost all of the further steps here, you always have an option to enter a U value for the insulation or that product or that window or the door that you're installing. So if you don't see your selection in the drop down, but you have the U value, just use the U value to type it in and use in the calculations.
That's usually supplied by the manufacturer, right?
Yeah.
All right, let's talk about the ceilings. Ceilings make a big difference, how high they are and how well they're insulated.
Yeah, similar kind of step to the previous step two that we did. We duplicating the ceiling area unless it's different, inputting the information about the ceiling height, and again, we telling the system what's above that room. So in other words, what type of ceiling that is or what it is above. So again, if it's just heated room, the system just going to prompt you to continue, because we know if it's a heated room, there is no such thing as a heat loss because you're talking about 2 heated areas. But if it's, a roof ceiling combination or of some sort, we again want to enter exact R value from the drop down, or just use your particular U value or the R value that maybe was supplied by contract or any paperwork that you have. And the trick here, if you know the R value of the product, but the calculator here is asking for the U value, never put the R value there, because that's just going to mess up the numbers completely. The U value is pretty much an opposite to the R value. It's inverted R value. So what you want to do is just make it 1 divided by the R value. That's going to be U value.
Right. So keep in mind that these are really, really important things to put in for you to get the right answer. Now, you're only putting information in for one ceiling. You're only putting information for one floor. Those 2 are easy. The rest of the stuff we'll get to later. But the number one question I get from people who are kind of not really, who's never done one of these, is they have, okay, my basement's 3,000 square foot, and then I want to heat 5,000 square foot above that in the first and second floor. So what do I do? Do I pick the entire floor, like the upstairs floor? Do I pick out the 1,500 square foot for that floor and then do 2,000 for the first floor? No, you do one of these for each individual room. That's the thing. If you're doing a first floor, you don't put the total square foot of the entire first floor. You put the square footage of the den. You do a room construction for the kitchen. You do a room construction for the den, and so on and so on. So this isn't just a mass thing for the first floor of the house. It's each individual space in that house.
Yeah, and that definitely a number one question that we're getting is about doing the heat loss, and that's what I'm also recommending most of the time is like do the heat loss calculation or supply us the information about each room that we're trying to heat here. So we're going to be doing that room by room, because in the very end of the whole process, the benefit of using the floor heat as a primary heat of source is that you actually maintaining a perfect climate in each room individually at any specific time and day. So that's a very great part of it.
And the good thing is it lets you edit over here too. There's an edit button that you can use to change any of this information.
Yeah.
If you go and look at it, it's like, oh boy, I forgot to do this. Then boom, there you go. The ceiling, I forgot to add the skylight. Oh, we're so happy with our house. We have 17 skylights in our bathroom. Uh-oh, that it could be a problem with heat loss. So this is what the page looks like, right?
Yeah, that's, after you went through these 3 main steps, you will have pretty much your overview. But then, moving on to the ceiling, you still have that option, just like Scott said, of adding 17 skylights. Feel free to do that if you go with a 17, but if you have, 1 or 2 skylights, put the number, the dimension of it, or if you know its exact square footage, just type it in there, choose the glass type, choose the frame type. Our system will do the calculations to estimate that R value. But again, if you you buying that brand new skylight and you have a sticker that says right there, U value 0.21 or something, just supply that number because that's going to be the most accurate information that we can put here.
So here's where we go, where we've made the ceiling, we've made the floor. Now, if you have an octagonal room with 8 different walls, this could take you a long time. Okay. So it's just, it has to be done though. Each individual wall may have zero windows. One wall may have an exterior door, which can be devastating to heat loss because you're actually opening the door to walk outdoors. And as you're walking out the doors, all the heat in the room is following you out. So this is where you actually construct that exterior wall.
Yeah. So exterior wall is pretty much, like Scott said, if you have, 3 walls here or something, you will need to do each one individually, but it's really, should be pretty simple. You put in your square footage of the wall or simply, dividing the length, multiplying the length and the height. The system will put the square footage for you, choosing the wall type from that drop down below, selecting what's that insulation or wall, kind of exterior wall insulation type is. And same thing here. If you know the U value, you kind of have your architect or builder specifying exactly the details. You have that U value, type it in there.
Once again, kind of recapping as we go along. If you have a room that has 0 exterior walls and you have a room that has 3 exterior walls, which one is going to start out colder?
Definitely the one with more exterior walls.
Right. So that is, once again, getting the common sense into the calculations here. You can start walking into a space and go, oh, this might be a good candidate because there's no windows. All these rooms are, all these walls are interior walls. There's no exterior. Okay, so let's do a calculation on that. You walk into a room that's 4 exterior walls, windows in every single one of them, a fireplace and skylights. You could go, this is probably going to be tough to get this to work. But that's going to come after you do a few of these. You'll start to get an idea of, oh, I see this room may be better matched than the other room is. So let's talk about exterior walls sometimes have
windows, doors. So as soon as you might be kind of a common question be, where do I start adding doors or windows? You cannot start adding doors or windows in this tool until you add an actual exterior wall with all the information. So like in the example, kind of on that image on the very top of the slide, you can see exterior wall is added, and then it prompts you to add the window or add the door or add both of these or add multiple of these. So adding the window should be pretty simple. You adding the square footage or, again, height, length of the window. Window type, either it's a single pane window or it's a nice triple pane window that's going to really save you the BTUs and save you the cost of the system here, the operating cost. Glass type, frame type, once again, all of these little details going to contribute and change the the overall result here.
So exterior doors.
Similar type, similar approach, follow the prompt, pick the closest. If you know the exact information, great. If you don't have an exact information, pick the closest or worst scenario option just so we can dial that heat loss numbers to be kind of the closest to the accurate, to the closest to the realistic numbers.
A room that has an exterior door, if that door is open 0 times per day or 1 time per week, is that room going to naturally stay warmer than a room that is like the main entryway in and out of the house where the door opens 10 or 15 times a day?
Yeah, it should be warmer if you open it less. Yeah, sure.
Right. So keep that in mind. So let's take a look at the heat loss breakdown for no exterior wall. So what are the numbers here that we're cooking up?
The thing I like to point out is that pie chart, that the less pieces we have, the better scenario we should have. So this is pretty much, this is what you will see as soon as the calculations are done. So you will, of course, will have just the numbers on the top. So your total loss is 1,380 BTUs per hour. Then the kind of the visual information that I always like to look into is that pie chart, because you can see here it's pretty good result. You have infiltration heat losses of about 600. You got heat loss through the ceiling about 400, and the underfloor about 350 BTUs. So you don't see any significant monster. I mean, of course, infiltration can be the one, but that's the common thing. You will have it no matter what. And yeah, I mean, this is another great visual information for this particular case is what we call it a room versus outside temperature. So the blue line, or kind of the blue chart with this kind of higher and lower points there, is your outdoor temperature that we actually pull based on the zip code. So we know it's, January, February are pretty cold there, but then of course it's warm throughout the summer. And the orange line is just showing you what the room temperature can stay at with the floor heat running. So this is, once again, we're talking about this nice scenario with no exterior walls. Of course, there is, pretty good low heat loss, and the temperature can be maintained at, in this case, looks like it's 68 degrees throughout the whole year. So all of the days in the year should be just fine. Same thing here is just heat loss versus heat supply. So, our blue line, the blue chart below is just indicating the average heat loss. So you can see kind of how the heat loss is, of course, higher in January, February, December, because it's, of course, colder part of the year. But the heat supply that WarmlyYours heating system can provide is constant, and it's at 4,000 BTUs, because we calculated that based on the square footage.
We apologize to those who are in South America, South Africa, and Australia, because these are kind of inverted from what you're going to go at. Your coldest months obviously are going to be July and August. So we apologize, but we had to pick a lane and we're sticking with it. Does your zip code field accept Canadian postal codes?
Yeah, the tool will work just fine for, US zip codes and the Canadian postal code, so it should be no problem.
So let's take a look at what you get at the end of your study here. This is, once again, with no exterior walls. So what is it telling us here?
So after reviewing all this information, you will have kind of a nice section with just recommendations. So in this case, it will just say WarmlyYours temp zone with about 80% of the coverage will supply 4,000 BTUs. And in this particular case, the WarmlyYours system can be a primary heat source for the room because the amount of heat we provide is larger than the heat loss. So that's a perfect scenario. We always like to kind of see how big is that difference, but as long as we know the WarmlyYours system can provide more than the heat loss, that's already a good sign.
Right. Now, if you take a look at this, 80% coverage is assumed because in a bathroom, if you took your square footage of your bathroom, let's say it was 100 square feet, if you don't heat your shower, you can't heat under permanent fixtures like cabinets, under toilets, that sort of stuff. By the time you start taking those things away, you're left with about 80% of what's left. So that room would be, that's a question for Olivia. Sorry, we're going to get rid of that one. Sorry. So we just want to make sure no question goes unanswered here. So thanks for sticking with me. But if you were doing this in a living room or a bedroom, let's pick a living room, because a living room, if you don't have anything that's a box bottom sitting on the floor, you can ask for maximum coverage, which could get you anywhere between 4, 6, 8 inches from each wall. That way, normally we would say if you're not doing a room heat for primary heat source, we can pull off the edges a little bit and only put the heat where you walk. That helps with a couple of things. It helps reduce the cost of the purchase. It helps reduce the cost of the electricity, because what you're doing is you're just heating the area of the floor that you're going to be walking on, 80% of that space. Let's say if you want to use it for, I want primary source of heat, we may go into the 90, 95% of the available floor space to get more BTUs in that space. So that's how different rooms plan out with different amounts of coverage. So that's why the 80% is covered here, because we normally only heat the part that you walk on.
Yeah, and the good thing, I mean, we talking about an example here where you would just, finish watching the webinar and go straight there and start doing the heat loss. These are the recommendations that you will receive. However, if you send us a floor plan, a couple of days ago, and we designed a room for you. We know exactly your coverage. When you go, 2 days later, you go and do your heat loss calculation, we will already know exact number of BTUs. We're not going to be even using the percentage because we already designed a plan for you, and we know your system going to give you 4,555 BTUs because that's the heating mat that we're installing. So once again, the closer we get to this kind of designing stages and heat loss stages, the more accurate information we can kind of get to.
Now, keep in mind, we had a question from Brian. Is it better to run the system full time as a primary heat source or time it? Well, you can see that it's called out here in the results. This is assuming that the primary operation will be 6 to 8:30 a.m. at highest temperature, set back between 8:30 and 5. Then at 5, it goes to the warmer temperature, and it stays to the warmer temperature till 11, and then it kicks down to the lower temperature overnight. Then on Saturdays and Sundays, 6 a.m. to 11 p.m. So that's what the assumptions are made. If you are going to, change that, the numbers may end up a little bit different. So we had a question from Ken. The type is so small that I can't see what Ken is saying. Are your cables far infrared, short, medium, or long? They're far infrared. All of our products emit a far infrared wave that is used for the warming. So hopefully that answers your question, Ken. So let's move on to the next one. And do not pay any attention to what's going on. Okay, so now let's talk about the heat loss breakdown with an exterior wall. Yeah. So there's more pieces to the pie, aren't there here? This is making me really hungry.
Definitely more pieces to the pie, more monsters, more blue collars here.
Oops, sorry.
And yeah, I mean, now we're talking about a more realistic example. We're talking about a heat loss where exterior wall is, taken into the calculations. Then, of course, we have a door, we have a window there. So still kind of similar breakdown here in terms of, you have your infiltration, you have underfloor heat losses, ceiling losses a little higher. Maybe we picked, slightly lower R value because it's an older construction. And then you have your door, your window, and exterior wall. So as you can see, still, this exterior wall with a window and the door gives you, it's about a good quarter of the whole heat loss. So if, for some reason you added the exterior wall, but let's say you're not sure on information about the doors and windows, still add that in just to at least start getting some ballpark, because as you can see, it really contributes to the heat loss. And in this particular case, the total gets to about 6,600 BTUs per hour.
So let's see how that affects this chart.
So yeah, now this chart becomes a little different. New lines are appearing. And as you know from the previous description, so blue line is your outside temperature, varies throughout the year, just like it would. The blue line with those blue circles that kind of stays at 68 is constant because that's your desired room temperature. That's what you want. But in this particular case, because we're talking about really enormous heat loss, that orange line that is it
separates right here, right?
Yeah, it's a reachable temperature. It can really reach, looks like what, from April until November.
Mm-hmm.
The month of January, February, and March, and December, it looks like that temperature going to go down simply because we're producing maximum amount of heat that we can into this particular room. And that's actually a common question. People would call and ask, what can I do? What do I do? What system do I buy to get more heat, to make it a primary heat source? We already providing the product with that highest wattage per square foot. We put in as much heat as we physically can, as long as we're covering that whole square footage. But at this point, if we're talking about this scenario, it kind of becomes, it's not depending on us at this point. We cannot do more. It's the heat loss that just takes all that heat away.
Exactly. So this is a really good, I love the way that this separates. Let's take a look at this one now too.
Yeah, same thing here. So we're comparing the heat loss versus heat supply. So again, the blue line is your average heat loss. The heat supply is the orange, that of course stays the same because we providing that maximum all the time. And as you can see, the blue line kind of goes above that heat supply that what WarmlyYours can do. And of course, again, it's on those months where it gets colder, where the heat loss becomes higher than the heat supply. So just kind of same problem, just look from two different perspectives.
So now this, we're going to read it and weep, aren't we?
Yeah, so we have still same thing, 80% coverage. We providing 4,000
number of BTUs.
Yeah, 4,000 BTUs per hour. Nothing changing here because we're talking about the room with, you know, same example, just different heat loss. But then the second bullet point, of course, will indicate that that system can now be a supplemental heat source for this room, and you will need a primary heat source to reach your desired temperature for those specific, you know, month where, you know, what we saw on the previous chart.
Right. So it also gives you hints here, right?
Yeah,
about what you can do.
Yeah, it kind of gives you the information, pretty much really duplicates the information you see in the chart. You know, it tells you ceiling, exterior wall. These are the things that you want to kind of replace or add the insulation to. So kind of, again, gives you good information in terms of what to look for, kind of where those monsters are hiding.
Right. So that's kind of like the two different types of reports. One, yes, you can. One, no, you can't. Let's see. So yeah, you kind of get an idea here of why these exterior walls and windows and that sort of stuff becomes so important. What do I see here in this picture that warns me that this might not be a good situation for a primary heat source?
To me, it looks like there is a door that leads to a huge wall/window combination that leads to a nice ski resort area or something in the middle of the winter.
Exactly. That looks like a great big heat loss monster to me. So what about primary heating with electric floor heating? EFH means electric floor heating for those that are not familiar with that. So what can we go through on this slide?
Yeah, so this slide, I like the information here because here we pretty much talking about, like, let's just say you ran that first example. Your heat loss is 3,000 BTUs. You can provide 5,000 BTUs, kind of perfect good scenario to run the system as the primary source of heat. First thing you want to do is make sure your thermostat is set to the room or room with the floor protection mode, because that's the way you control it is the most important part. You want to make sure that if you want to control the room temperature or maintain that room temperature, you want to make sure your thermostat knows what you're doing. You don't want to just set the floor to 80 degrees or 75 degrees and think that your room going to get warm. It should, but it's not the right way to control it. The other thing is low temperature setback. Again, this type of heating approach is different than your forced air heating. With this system, you want to really be, and I would say there is really no one straight answer here. You really want to kind of run through some experiments and see kind of how quickly your room heats up, how quickly it cools down, and then based on these details, set your low temperature setback. And kind of, you know, the example here, you don't want to just
set it to 50.
Set it to 50
yeah,
and then
it's going to take a long time to get back up to that.
Thinking that it's going to warm up in like 20 minutes. It may not do so.
What's the great thing about primary heating with electric floor heat is the zonability of it. If you have a basement that gets used twice a year, Thanksgiving Day and Christmas Day, there's no reason to have a furnace in the house blowing the same hot air into every room. If you're only using this room once or twice a year, you turn it on once or twice a year, and then you leave it off the rest of the year. That's what's so great about electric zone heating. You have 2 spare bedrooms, don't turn them on. There's no need to heat that particular place because there's not going to be anyone in it. So that's what's great about primary heating with electric floor heat, because it's so zonable. Each room has its own control. Each room, you can either turn it completely off if you want to, or turn it on Thanksgiving Day or on Christmas Day. How often do you actually use your dining room? 2 or 3 times a year, right? Or when people come over. Why heat it? Why heat that room when there's no one there? Turn it on for 2 or 3 times a year. That's what's going on with, that's kind of like a built-in feature of this product, is it's not sending heat everywhere in the house, and you're not heating every square inch of the house. You're heating it where you're needing it.
That's definitely the part I like the most, because I mean, even a super simple example, you can just run your bedroom and bathroom throughout the night and just have your thermostat running on schedule, and then start to heat the rest of the rooms in the morning when you wake up. So as simple as that.
Right. And also, once again, a choice of carpet that is limited to 82 degrees or a limit of tile with no limit. Which one is the best choice for sole source of heating, primary heating?
I would go with tile.
Right. Keep that in mind. That's a common sense thing that a lot of people don't really think about. So there are going to be some time in the year, during the year, where there is not enough BTUs available to heat that space, right? So on those particularly cold days, and some days it may only be 1 day or 2 days for the year that are not going to be able to be heated. That's where these things come in. What is this thing? Is this the black hole, or what is that thing? A portal to a different dimension?
What you just said, Scott, is for sure. Especially with the current climate change, you never know what the temperature, what the weather is going to be tomorrow. So anytime you run into the scenario similar to what we were just talking, where the system needs some help, needs some secondary heat source, that's where you can use the radiant panels, for example. You can use it as the additional heat source. So like if you're lacking 853 BTUs or another 3000 BTUs, add a radiant panel of the correct size based on the BTU, based on the numbers. And again, we can assist you. We can help you on kind of getting that figure out better. And that will supplement, that will give extra heat to that room that just doesn't have enough maybe floor space to install the floor heat properly.
Yeah, so that's one thing to keep in mind, that you can get that. Believe it or not, there are people that don't know that you can actually, there are people that don't know you can heat floors. Believe it or not, there are people that don't know that. So what happens is their room is warm all but maybe a week during the year, and they don't want to rip up their floor to get BTUs into the space. These radiant panels are great for people that have missed the boat with floor heat. They can actually fill this space, this bedroom or this bathroom or whatever. They can fill it with radiant panel heat. So these can also help you piggyback them together and actually make it a little bit warmer. We had a question about baseboard heat. A lot of times we get questions about baseboard heat all the time. Once you do your heat loss calculation, you know how many BTUs are required. You also know how many BTUs our product will provide. If it's 500 BTUs too few, you put a 500 BTU baseboard heater in. That's how you would size your baseboard heater. Or if you already know that your baseboard heater has 1,000 BTUs, you need 2,000 to heat the room. You just need 1,000 BTUs provided by something else. Yep. So that's how baseboard heaters are involved. A lot of times people call us and go, yeah, I've got a baseboard heater. The baseboard heater was made in 1964. They don't have any information about it. They don't know how many watts it is. They don't know anything about it. We can't give you that answer without knowing what that baseboard heater is. But if you say, yeah, I've got a 1,000 watt baseboard heater, then we can start putting the pieces together. But if there's no information, you say, I've got a baseboard heater, sometimes it works and sometimes it doesn't. How many watts is it? I don't know. What year is it? I don't know. Who made it? I don't know. Then, we can't give any good information if we don't get any good information. So can the wall panel get wet? These panels can be put in the bathroom. They should not be put in a place where the shower water is going to hit them on a regular basis. But they do have a protection that will keep an occasional splash off, but it's not designed to be put next to a shower. So that's where these panels are best put. So you can see it's got a good placement there. Also keep in mind they get really, really warm. So if you have toddlers, you might want to get a panel that might be a little bit smaller and you might move it up a little bit. So that's just something to keep in mind there.
It looks like we also had a question from Scott. Scott was asking, can output of floor heat be variable based on demand using a smart thermostat? For example, floor heat to 75 during low demand and 85 during high demand. So I think to properly answer that question, Scott, and unless my Scott here to correct me, in this particular example, it sounds like we're talking about running the thermostat based on the floor temperature. So yeah, if you rather run the thermostat on the floor temperature sensor settings, yes, you can simply set your thermostat to a floor temperature that you want, either it's 75 or 85, it will still contribute to your room, to the, to heat the room, but you're actually controlling the floor temperature. Versus typically, if you're trying to heat the room, you would rather control the room temperature, and the system will just turn on demand to maintain the room temperature that you want.
Right. But if you're, the thing is, we could sit here for another hour, and I don't think we have time for that. The thermostat, a common, and I'm going to go through the common misconceptions about thermostats. One is that they regulate the temperature by regulating the voltage. They don't. A thermostat's either on or it's off. It's either feeding 120 or 240 to the floor, or it's off, not feeding power to the floor. It's based on a duty cycle. And here we go. This is going to be 1 minute, not 25 or 30. But the way it does, you'll see multiple, maybe 5 wavy lines on the thermostat. Then sometimes you'll see maybe 3 on the thermostat. That's showing you the duty cycle. So if it's calling for heat and it needs all the heat it can get, all the things will be lit up. And if you picture 15 minutes on a clock, it's heating all 15 minutes of those 15 minutes. If 2 of the 5 wavy lines are on, it's heating 7 of the 15 minutes, and the rest of the amount of the 15 minutes, it's off. That's what we call a duty cycle. You split it into little pieces like 15 minutes or 10 minutes or whatever that manufacturer does, and then you make it be either on for 10 minutes or off for 10 minutes, or on for 3, off for 7, on for 4, off for 6, et cetera, et cetera, et cetera. That's how it regulates the temperature of the floor. It doesn't take 120 volts and only send 80, or then send 90, or send 40. It doesn't do that. It's all completely on or completely off for a duty cycle. I think there's some more questions here. Thank you for the question.
There's at least 3 questions. I'll jump on Jessica's question here real quick. Jessica is asking, can you put one of these panels next to a front door and hang a coat on the corner to dry the coat on a rainy day?
I would not.
Yeah, I would
not take
do
something
that,
wet and put it on there.
Too. That's, again, we're talking about radiant heat, and anytime you're trying to kind of dry something, that's more of a different approach, I would say.
Yeah, and you may not know, but these things can get hundreds of degrees, over 200 degrees. So that's not something I want to put my coat on.
Yeah,
it's it's like buying an iron. It has to be hot for it to work. So that's not something you want to put anything wet onto to dry it out.
Matt is asking, why does the integration kit with floor sensor not work with the Nest Thermostat? So the answer is pretty simple. It all depends on the thermostat of your choice. Nest Thermostat simply does not support any external or floor sensors whatsoever. So you would just use an integration kit with a Nest Thermostat if you want to. But again, there is no sensor connection there.
Right. So you can't control the floor temperature if you have no way to connect a floor sensor to the control. So a Nest would be a good pairing with a tile floor, because there's no limit on the tile floor how warm it can get. It's a very, very bad connection to try to regulate the floor temperature of, say, I wouldn't even recommend it with laminate. I wouldn't recommend it with engineered wood or carpeting, because that literally, if you open the window and somebody's in that room moving around, the Nest is going to be calling for heat, and it's going to be on full blast, and there's no way to regulate the temperature in the floor. So the floor could actually get 100 degrees when the limit that it's only supposed to get to is 85. Yeah. So there's no way for Nest to see the temperature of the floor, and there's no way for it to regulate the temperature of the floor.
And just to clarify, Matt, we provide the integration kit with a floor sensor because there are a number of thermostats on the market that are, low voltage thermostats. They need an integration kit, but they also do have a floor sensor connection. So that's why we always provide that option, because there are, options, especially home automation options on the market for that. Ken has the same question. I used MISA thermostat that graduate the tension on need. Will your wires be compatible? Actually, Ken, this morning I was researching that MISA thermostat. So it looks like a new unit on the market, new product on the market that is, from what I see, should be fully compatible with the floor heating. We actually, again, still in the middle of the research, but it seems to be a line voltage floor heating thermostat that has a floor sensor. So it should operate just as a normal thermostat. You would just need to probably look into their settings to see if it can be switched between a room and the floor temperature.
And then Jessica said, is there a concern with children touching the radiant panels if they get that hot? Yes. If you have toddlers, we suggest that you put them out of reach until they get old enough. Would you let a toddler handle an iron? I wouldn't.
Yeah.
But when you're grown up, you can. So it's one of those things. Fortunately, I haven't grown up, but I have learned how to use an iron. So those terms are not always mutually exclusive. So I would say if you do have a toddler, you see how that I'm going to go back and see how that was mounted up and down vertically. You could actually take that panel if you have the room and turn it horizontally and put it up a little higher so they can't contact it until they get a little bit older. So hopefully that answers your question, Jessica. Any more questions that we can amaze or befuddle you with answers? If you don't have any at this point, you can always send them. We're going to give you some contact info. You can send us. If you got this invitation, you just reply to the same email. But our next webinar is going to be Thursday, December 12th, for our 4th month of winter already at that point. It's going to be installation tips for outdoor radiant heat. So that's what we're going to be doing on December 12th, 1 p.m. Central Time. There is a daily training that goes on every single day. Anatoly does some, I do some, Greg does some of those. They are every day, Mondays at 4, Tuesdays at 11 and 4, Wednesdays at 4, Thursdays 11 and 4, and Fridays at 11 a.m. If you have a Dr. Pepper, then it's 10, 2, or 4. I'm just kidding. I'm old. I remember Dr. Pepper advertising. They did a really good job. So let's talk about our monthly promotion. What's our monthly promotion?
Yeah, so the month of November, we do 20% off of Environ Easy Mats. So that's the product, as you can see right here. That's the product you want to use for the installation with carpet, laminate, or floating wood.
And it does not glue to anything, and nothing glues to it. That's a perfect way of remembering what the type of use this is. So those are really, really nice, warm, big blanket panels that you just lay out on the floor. The easiest to install, very, very quick. You lay them out, you cover them up, and you hook them up to a thermostat, and you're ready to go. So please take advantage of that sale. They are awfully cool. So we do value your feedback. I hope you learned something today. I hope work under luxury. Oh, fantastic question. We get this question every single day. I can't read the name though. Is it
Emery?
Emery?
Yeah.
Will the Easy Mats work under luxury vinyl tile? And the answer to that is no. Luxury vinyl tile, we have a video online. You go to WarmlyYours.com and go into Learn and then click videos. And there is an installation that we did with LVT that shows you exactly how to do it. It's done with a temp zone product covered with 3/8 to 1/2 inch of self-leveling cement. And then you have a nice flat floor to put the luxury vinyl tile on. So very good question. You're welcome. Thank you. You got in the nick of time, and it's a question we get every single day. So I'm glad you asked it. So we do value your feedback. You'll receive an email shortly asking about your experience today. We appreciate your comments and suggestions. And if there's something that you want to learn about, please tell us instead of us going, gee, what should we do our webinar on this month? Anybody have any idea?
Right.
It would be great if you said, why don't you guys talk about this? That would be great because then we know you're interested in it. We can then give you the answers you're looking for. We just try to give things that we get questions about ourselves all the time. So that's kind of where we do our best. But your feedback here is very, very important to let us know what you would like to see discussed. If you have any more questions, you can contact us here at Warmly Yours. Our toll-free number is there. Our emails are right there, info@warmlyyours.com. Get you into our system, and then we can get you taken care of. And you can go to our website. We are on social media all over the place, which you have to do these days. So you can find us there if you need us. And we really, really appreciate you coming and visiting us today, taking the time out of your day to join us. So until next time, be warm and
be radiant.
So long, everybody.